this rack are 7 test tubes filled with different oxygen-containing organic compounds. They may all look the same to you, but each of these has its own set of physical properties like melting point, boiling point, and density. Each of them also has unique chemical properties. Their activity is determined by a portion of the molecules called the functional group. The functional group is also the basis for classification of the hydrocarbon derivatives. Let's take the first 2 test tubes. A contains methanol or methyl alcohol. B contains ethanol or ethyl alcohol. Alcohols have the general formula ROH. R is a root or parent alkyl group. OH, the hydroxyl group, is a functional group. The names methyl alcohol and ethyl alcohol are common names. The systematic names are methanol and ethanol based on IUPAC rules. To name an alcohol, determine the parent alkane molecule. The stem or root indicates the number of carbon atoms in the longest continuous carbon chain that contains the hydroxyl group. Attach the suffix OL to the alkyl stem or root. The ending OL indicates the presence of a hydroxyl group. Methanol is derived from the parent alkane methane. Ethanol from the parent alkane ethane. A 4-carbon alcohol is butanol. It may be either 1-butanol or 2-butanol, depending on which carbon the hydroxyl group is linked. Some alcohols have more than 1 hydroxyl group. Those with 2 hydroxyl groups are called diols. For example, 1,2-ethane-diol, commonly known as ethylene glycol. It is used as an antifreeze and as an ice substitute. The triols have 3 hydroxyl groups. 1,2,3-propane-triol is also known as glycerol or glycerin. Glycerol is a component of many fats and oils. The hydroxyl group makes the smaller alcohols from methanol to N-butanol soluble in water. Larger alcohols are not miscible with water because of the large nonpolar alkyl portion. Alcohols with more complicated structures also occur in nature. Menthol is found in peppermint oil, geraniol in rose or citronella oil.